Good evening to one and all present here. I am Ujjwala, and that is Nthenya. Our project is Mobile SIP. The main goal of our project is to develop a software-based cellular network which operates on SIP protocol to communicate with other networks. So to establish this, we used a software known as 8BTS. 8BTS interfaces with the Blade RF, which is a transceiver that transmits and receives the radio signals. So this is our overall project setup. You can see the server there. The 8BTS is run on that server, and the small equipment there with the two antennas, that is the Blade RF, and we have two mobile phones, which are actual just normal mobile phones that has SIM cards, which are registered to our 8BTS network. And we also have soft phones that can be run off of any laptop. 8 and 8BTS. So 8 is the abbreviation for yet another telephone engine. 8 has the ability to do voice and video and data communications. Our project goals. We have 3 goals for this project. So first goal is to make successful calls between the cell phone and the soft phones. And the second goal is to make emergency calls to the EZNet. EZNet is the Emergency Services IP-based network. And our third goal is to understand how 8 enables calling between 2 user agents that are behind NATs.
So our tasks and milestones are as follows. First, we built the software-based cellular network, and we did this by installing 8BTS and linking it to the Blade RF transceiver. Then we made calls between different user agents that are registered on the 8BTS network. We then established a peer connection between the 8BTS network and the EZNet, and then we went ahead and made calls from a user that's registered on the 8BTS to the EZNet, and then we collected calls and we collected and analyzed traces from these calls. We also finally tested SIP calls that were made between users that were behind single and double NATed domains. Our physical architecture is set up as follows. We have the 8 server that is right here. It is our core engine or proxy where we have our users that register to it. So we have the user agents, the soft phone user agents right to your left, and then we have our transceiver that's connected to the 8 server via a USB cable. And the transceiver is the one that picks up radio signals from the cell phones. Our logical architecture is set up in this way. So we have our 2 handsets that I described earlier, right here, and they are connected through the Blade RF. The Blade RF is the one that receives the radio signals and converts the radio signals to SIP. And the SIP signal is then sent to our 8BTS. So this entire setup represents our 8BTS. The SIP signal is received by a radio transceiver that's in the 8BTS. It's then sent up to the MBTS via an inter-process communication socket. The MBTS acts as our modem. It converts analog signal to digital signal. It also acts as a radio resource manager. So it allocates and assigns channels between handsets and the network. So once the radio channel is established, the frames are then sent to the YBTS. The YBTS is a 8 module. It looks at the signal or the message that's received and determines what kind of request that the message is. It looks and sees if it's a register or a SIP call or an SMS. It then creates a 8 message that's specific to that request, and then sends that 8 message through the 8 engine to the respective module that will handle that request. So the 8 engine serves as the core engine, which determines which module, or rather directs a message to the specific module that will handle the request. So the main module that we've been working with is the JavaScript module that's called a NIB. The NIB that stands for Network in a Box. and this module handles RTP and SIP messages. And then we have a comparison between the YATE BTS network and the conventional GSM network. So our YATE BTS network, essentially, the YATE BTS part represents the radio network. So it aims at substituting the BTS and the BSC in the radio network. And then the NIB serves as our core network, so it serves a purpose of representing the core network in the GSM network. So when we want to register a user in the YATE BTS, we have to add them into the NIB. And these are some of the core information that we have to put in. So we have to put in an IMSI, which is the International Mobile Subscriber Identity. We have to put in the MSISDN, and we also have to put in a key, which serves as an authentication tool for the subscribers. So when we make a call between two cell phones, we collected the traces and we got a ladder diagram that is set up as follows. So our originating side had the number, the 85, ending 8510, and this was the terminating side. So when the originating side makes a call, a service request is sent to the YATE BTS. The YATE BTS will respond with a connection confirm, and then the YATE BTS goes ahead to set up an authentication process. After the authentication is done, the YATE BTS sends a service accept and then starts paging the terminating side. The terminating side will respond to the paging response, and then YATE will stop paging, and then a communication channel is set up, and we get media that's exchanged. When the terminating side wants to hang up, he sends an alert message to YATE BTS, and YATE BTS will disconnect the call, and then YATE BTS will go ahead and release on the originating side, and the originating side will respond with a release complete.
This is a trace of a call made between two user agents that are registered on the YATE BTS. So the first line represents the user agent 1, and the second line is our YATE server, and the third line is our user agent 2. So we can see all the SIP signaling messages here in white: 100 trying, 180 ringing, 200 OK. And one interesting point to note here is that we can see all the signaling goes to the YATE and back, and also the RTP goes to YATE and to the other user agent. So the YATE acts as a back-to-back user agent and maintains two different calls with the two different user agents. This is a trace made between a soft phone and a cell phone. We could only capture the soft phone side because the other side is on air. So here also we can see the SIP signaling messages, but also we can see 183 session progress, which indicates that the call crosses a gateway. The observations. So from the above ladder diagrams, we can see that the YATE acts as a back-to-back user agent and also as a SIP proxy and a registrar. The important module in YATE BTS is a network in a box. That represents the core of the network. So it takes care of the user authentication, call routing, and SMS handling. The calls from cell phone to cell phone and soft phone to soft phone were successful. We could get the SIP signaling as well as the media from end to end. But in a call that we made from cell phone to soft phone or the soft phone to cell phone, we could only get the media, SIP signaling through, but we couldn't get the media through. This might be due to some misconfiguration that we did in YATE BTS, so we are working to correct.
Our second goal was to establish a peer connection between YATE and the EZINet. We did this by configuring the dial plan in the YATE server. The dial plan essentially was meant to tell was supposed to actually look at the call and identify if it's an SOS or an emergency call and direct it to the BCF. So when a call is made from either a soft phone or a mobile phone, the YATE server will receive the call, look at the call, determine if it's an SOS, and then will forward it to the SBC if it's an SOS, and then the SBC forwards the call to the ESRP and the PSAP, and eventually it's answered at the call taker. So now we'll show you a demo of a call that we made from one of the phones that are registered to the 8BTS. Okay, we'll have to show the demo after because we're not able to get it right now. I think, yes. Yeah. Maybe while she's doing that, we can go ahead or just wait. Okay, she'll get it.
Basically, thank you for the presentation. If they can get the, if you have questions, perhaps while she's getting it, you can answer questions or comments. Actually, we should give it to him.
So I was just thinking about the Yates server being a back-to-back user agent. I was wondering if it could help, if you could use that to help with the other gentleman that did the mobile app and was trying to choose between the different messages, SIP info, and since I think the back-to-back user could just rewrite the message, right? So it could possibly do some analysis there.
Yeah, so yes, it can definitely help with that as a back-to-back user agent because it recreates the call. But the one thing we'd need to find out is if it recreates the call, can it still send the location information that it received? So we'd have to make sure that we're able to, to match the fields and implant the XML that contains the location information.
You'll have to
Yeah.
take this out. We actually tried, while they're setting it up, I'll tell you, we actually tried at one point to send our calls that had the location information. We tried sending them to Asterisk and then having Asterisk peered to our session border controller. And Asterisk acts as a back-to-back user agent, so it recreates the call. But it does it from the perspective of a vanilla SIP, and it dropped our location on the floor, and it created it stripped it right out. So we were able to take SIP calls, but exactly what Francisco said. So what Francisco told you is, I don't want to change any information about SIP. And exactly what the back-to-back user agent does is changes information about SIP. All we wanted to do was carry this information in the body of the SIP message. Had nothing to do with SIP itself. It had to do with the two endpoints needing to exchange the information. So you exactly don't want to use a back-to-back user agent unless you've written special code for it that tells you take the entire body out here. But the point of a back-to-back user agent, it says, look, I'll talk to you and I'll talk to him, and I'll make I'll pass through your media. But it isn't media I'm trying to pass through. I'm trying to pass through actually data information. And that's why wouldn't work unless you wrote extra code for your back-to-back user agent. Yeah. Okay. Do we have other stuff, or should we just wait till next semester? Okay. 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 Yeah. All right. So we'll, thank you for your patience, and if Ujjwala and Nthenya are able to show, then we will. Otherwise, you can hold up your laptop too, and we'll never use my laptop again. I promise. It's not really my laptop, right? Okay. Okay. If you need a few more minutes, do you want them to go on with their demo? Okay, here, okay. Well, there will be a day where, okay. All right. Here's the demo.
So we're going to demonstrate a 911 call that we made from a cell phone that's registered on the 8BTS network, as opposed to a regular cell phone the cell phone actually has a SIM card that we programmed and registered it to the 8BTS. Yeah. Do we have audio? Oh, okay. I think you have. This is a cell phone that's registered to the 8BTS network. This is the PSAP operator on the Azimuth. I'm now going to make a 911 call, and the number representing our 911 is 12345. Okay. Look, this is a cell phone that's registered to the 8BTS network. This is the PSAP operator on the Azimuth. I'm now going to make a 911 call, and the number representing our 911 is 12345. Can you all hear? That's the call coming in. I'm going to answer it on the PSAP. On the PSAP, and then right here the top right is where it shows that the call is in progress and the call was answered and it's in progress. I know it's not very clear right now, but yeah, right up here. So yeah, basically just to go over the video real quick, we were just making a 911 call from the phone that's registered to the 8BTS, and we're using the number 12345 as opposed to 911 because we didn't want to make a real 911 call. So once you make the call, then as you can see, the call was going through the 8BTS to sorry. So our caller is at 10:15:98:20. He sends the invite to the 8, and the 8 will forward the invite to the SBC right here, and then the SBC forwards the call to the ESRP and finally to the call taker, and the call taker will then answer the call, and we were able to get RTP that was flowing between the two parties.
Our third goal is to study how YATE enables calling between two user agents that are behind different NATs. So this is our NTAP Test Bed setup. We have 3 main domains that have access to the public IPs. So the domain D1, the leftmost domain, it is a private domain in which we placed our YATE server. And the second domain, D2 and D3 are public domains. And D21, D211, D31 and D311 are private domains that are behind NATs. So as I said our YATE is in domain D1, and we placed 2 user agents in the other different domains and made test calls. And all of the test calls were successful. This is the results for our test calls. I would like to explain the test case number 7, because one user agent is placed in D211 and the other one is placed in D311, which are actually the bottommost domains in both the legs. They're behind 2 NATs. So the calls work even without the aid of a stun or turn server. This is because YATE acts as a back-to-back user agent, and it maintains 2 different calls with the 2 user agents. Also, the RTP goes to the YATE and then comes back to the user agent. So there is no communication, no direct communication between the 2 user agents, and hence it eliminates the need for stun and turn server.
So the next steps for the project are as follows. First, we'd like to resolve the communication failure that we had between cell phone and soft phone calls. We had mentioned earlier that we were able to make the cell phone to soft phone call, but we were able to get signaling, but we were not able to get media to flow from end to end. So we would like to still do some more tests and some more work on that. We'd also like to develop more test plans to further understand how YATE is able to play its role as for NAT traversal, and then we'd also like to upgrade our YATE BTS from GSM to LTE. Okay, that's it. Any questions or comments?
Thank you. I have to add one more thing that we want. We want to get a Wi-Fi, we want to get a cellular sniffer and a Wi-Fi sniffer because a lot of the problems that we see, and I see people nodding their heads, and if they want to tell me where we're going to obtain this, who's going to lend it to us, who's going to give it to us, but we need both of those things, and that we learned that so well. We were able to get our Uber tooth. We need the similar thing for Wi-Fi, and we need a similar thing for cellular.